Hey folks, Kellen here with another small program. This program is trying to solve exercise 14 out of the book Principles and Practice Programming Principles and Practice using C++. So the problem is write a program that takes an input value n and then finds the first n primes. So here's my solution. I first created a function called prime, returns a bool whether or not a number is prime or not. And the way I figure out if a number is prime, and this is not the most efficient way, but it works, is I simply look if the number is divisible by anything other than 1 in itself, that's a prime number, right? So that's what this prime function does. If there's any integer divisor that divides evenly into the input n, then the number's not prime, else it is. So here's the main section of the program. Here I'm just setting up a vector of primes. I've set up an n that reads in from the keyboard how many primes you want to print out. Then I've got this while loop and this gen primes. So as long as we haven't found the first n primes, we want to generate prime numbers, right? So this is what that if statement is checking. It's checking to see if we've reached, 7, 20 prime numbers yet. And if not, it checks to see if a candidate number, which starts at 1, is prime. If it is, it pushes it onto the primes vector. If the primes vector has a size greater than or equal to n, then gen primes is false. We want to stop generating primes because we've reached the limit of the number of primes that we needed to generate. And this candidate just gets incremented. There's nothing smart about this, like, it just goes 1, 2, 3, 4, 5, 6, 7, 8, like that, So all those are candidates for being prime. We don't know if they're prime until we pass that candidate into the prime function. So here's, let's run the program. So it's waiting for input. Let's print out the first 10 prime numbers. So the first 10 primes are 1, 2, 3, 5, 7, 11, 13, 17, 19, and 23. And I went online just to confirm that this is correct. So my program printed 2, 3, 5, 7, 11, 13, 17, 19, 23. So that seems correct. Let's see, 1 is divisible by itself. I think 1 is prime, right? Let's look that up. Is 1 prime? Oh, it's not. Okay. So let's start our candidate at 2. So I learned something interesting today. 1 is not a prime number because it only has one factor, which is 1. Prime numbers have to have exactly 2 factors, 1 and itself. So let's rerun this program with the change I made. I learn something new every day, folks. So primes.exe, the first 10 primes are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. 2, 3, 5, 7, 11, 13, 17, 19, and 23, and 29. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so let's, we can do a more thorough check. We can pass the program a higher number of primes. We want to find the first 100 primes. So here's the output of that. we'll just do a quick check to see. Let's see, 431, is that in the output? It is. What about 433? It is. Alright. So things look good. I think the program is correct. Of course, I can't really test against every prime number to see if it's, you know, completely correct, but looks like it did print the first 100 primes correctly. Okay, folks. Thanks for watching. Bye.